Absolutely.
Absolutely. Live Clojure Hangout. Here it is. Okay, so we've decided to do exorcism today, and the next I guess they're challenges, problems. I don't know. What do you call them? Exercises, I think. On exorcism is the nucleotide count exercise. Let me go ahead and throw this up in the here. So that those can be cleaned out by ShowNoter later. I told Jay earlier that like I'm using ShowNoter like 2 to 3 times a week.
Oh wow!
And that it's been like really cool because for Python Thursday Hangout, but then like whenever we do like one of these Clojure Hangouts or when we're doing the Code Newbie book Hangouts, I just grab the show notes, throw them into ShowNoter, and it's really handy. So it's been great for me that he put that together. So I let him know. Okay, so nucleotide count. Let's look this up. Let me start up the screen share. Okay. And we might not get the Tunnel of Doom. I'm trying this out to see if it'll thwart the Tunnel of Doom. It seems to be working. I like that.
I think it might be.
At least you don't get the full effect of the Tunnel of Doom.
Yeah, like it might be up there, but you can't really see it. So
exactly,
it's all right.
Out of sight, out of mind. All right, so let's clear this up. And nucleotide count, it is past project. Interesting. Okay. So let's make this. All right. So can you see that okay? Should I make the font a little bigger?
Let me. It's a little to the left. I don't know why.
Like it's offset somehow?
Yeah, so like when it was full screen, some of the letters, like the D in DNA, like I can see NA, but I can't see the D. It's weird.
Let's see if making this font a little bigger helps with that. We'll go to 20. Is that any better?
Yeah, it's pretty good.
Okay.
That's pretty good.
Okay, cool. All right, so DNA. I think I've done this in another language.
I think I've done this in Python. I'm not sure.
That might have been it.
Oh, occurs in the. Oh, I don't know if I did this one yet.
Oh no, you're right, huh? Because it was the matching one that we did.
Although I don't know how the tests look in this, but just from reading the first couple of things, counting how many times each letter is used, I think you could in Python. I don't know about Clojure, but in Python you could use like counter or something like that. I think.
Yeah, I think there was something. Now, I could be mixing up my languages, but I think there was something called frequency that counted how often something appeared. Let me look that up real quick.
Maybe. Some of these things in like these languages you don't even realize until you do challenges like this.
Yeah, totally. Yes, frequencies. This looks like it'll be very handy.
Yeah. We'll find out once we see some of these tests.
Once we see the tests, that's right. Shortest intro to biochemistry ever.
Like the A, ever.
Ever. All right. Twigs are to birds' nests as nucleotides are to DNA and RNA as amino acids are to proteins as sugar. My eyes are starting to get confused. Sugar is to starch as grab lipids. I'm not going to talk about lipids because they're crazy complex. So back to nucleotides. I'm not sure I'm feeling very confident about my biochemistry skills.
I can't say that I ever took a biochemistry class. I did take chemistry, but not biochemistry.
Yeah,
not
I
in
took
college
chemistry.
anyway.
I took chemistry. Biochemistry is when you get into like, isn't it all the compounds that have benzene rings and you get lots of carbons and hydrogens and oxygens and stuff going on?
Yeah, and the the ethyls and the esters and what's basic and what's acidic. So it's
Okay.
really when you start mixing things together. So like the pairs of the little DNA nucleotide sequences that would form the proteins, and then what do the proteins do to those chemicals to help you build the cells. I'm glad he's not going into any of that because it could get really complex really quick.
Yeah. Yeah, I agree. All right, so let's go to the tests because I'm not really sure what we're doing here other than counting some nucleotides. So let's go to it. I'm pretty sure I have line installed. Lineagen, but I don't know if I need Lineagen for this. This is actually there's a source directory for Clojure tests. Well, let's just try doing this and see what. Oh, there's a test file. Test folder. So we'll just do line test and hopefully my confusion will go away. And as you can see, I have not run Lineagen since I reinstalled everything on my computer. Okay.
Let's see.
Nucleotide count.clj. Now I think we need a source folder, so I'm going to make a
Yes, we do.
source, and then I'll go ahead and touch source nucleotide count.clj. What do you have for me, Lineagen? No such namespace nucleotide count. Okay, let me see if I can split up my screen here so I can do that whole thing. Two mocks. And then there we go. And let me see if I remember this. There and there. Good. So this one we'll go ahead and vim. This one. Line test. Okay, so we need nucleotide count namespace. If I recall correctly, that's just nuclear. Why do I keep typing nuclear?
Yes, that looks about right.
Okay, let's try this again. No such var nucleotide count. I'm going to guess that we need to make a count. And set some parameter of some kind, and it's going to return nil. No such var nucleotide counts.
Oh.
Now I'm getting confused. Okay.
This looks like it's going to be complex.
It does look like it's going to be complex. The def n nucleotide counts, and that's going to accept some kind of parameters, and we'll just make it return nil for now. Oh, it ran tests.
Oh, beautiful. 7 tests, 7 assertions, 6 failures, 6 errors. Oh, 6 errors.
That's no good. Probably because I already, wrong number of arguments. The nucleotide count is supposed to get 2 arguments. It looks like that. Oh, that's the character T, and then that is the string. So it's going to count the number of T's in that string, I assume? Yeah, because it's looking for 1. Counts only thymidine?
Yes, thymidine, I think.
Okay.
Yeah.
So we want... This is going to be called a... nucleotide?
I thought you were going to leave it as NUC.
Oh, let's do NUC. Like Three Stooges. NUC,
Yeah.
NUC. And then sequence is a reserved word, so... Or seek is a reserved word, so... How about... what do we want to use instead of that? Maybe... for that.
NUC, 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 NUC. Oh man, that's going to get confusing.
Well, I'm willing to switch it out. I just don't know what to call it. Oh, we still got 6 errors.
We still got... why do we have errors? Counts.
Oh, count. And it's got... Oh, I put the parameters on the wrong one.
Oh. I didn't even see that. Oops.
Oops. Only 3 errors this time. Okay. Number of arguments passed to nucleotide counts. Expecting a map. And no, it's expecting
Empty.
an empty string. Or I suppose this is the nyuk, nyuk, nyuk.
Oh yeah. Yeah, I would think so.
My naming conventions, I think I'm going to bring a lot to Clojure. Okay, so... so let's do this counts only thymidine. Or no, let's see. This is expecting a string and a character. This is expecting a map. Let's try that frequencies thing. Frequencies. See what happens. Something went wrong.
What did he do?
I don't know. Oh, I left out a close friend. Hey, there's one test passing because we have 7 tests and only 3 failures and 3 errors. What do we got going on here? Wrong number of arguments passed to core frequencies. Oh, we're doing it wrong. Oh, it's just a collection. But we need to turn it into a... Is that the sequence function? Okay, let's go here and say ling REPL. So then if I say nyuk, nyuk, nyuk. Okay, good. Then if I go this, that's exactly what I want. I love when I have no idea what I'm doing and it works anyway.
Frequencies.
What we want to do here is
So why do they have count and then nucleotide counts?
I'm not sure. This is to find an individual value. I think it's so that you don't use frequencies, honestly. But we'll see.
Oh yeah, they usually try and get you to think of your own solution.
This one's count. This. It seems like count is the function they're actually. It's like their core function. Oh, it seems like count is their core function. So A, T, G, and C are the important things, right? So if we say F, what do we want to call these? These are the ones that we're interested in. A, T, C, and G.
A, T, C.
Call them Nux, but that would just be completely confusing.
Yeah, then we'd really, oh my god, we'd get kicked out of Clojure.
We would get kicked out of Clojure. We'll call them valid.
That works.
So what this count is supposed to do is it's supposed to take a character and a list, and we want to the number of times. We want to filter an account, right? We want to filter down to just the ones that matter. Just going to look something like. So there we turn it into a string or a list from the string, and then we want to do a filter based on the nyuk. Okay, so this is going to take our string and filter out everything except for the one that we're looking for, and then we want to count it. Does that make sense? Maybe if I format this a little better, it'll make more sense. So if we're passed in the string ABCD, and this is A, first we're going to separate it out into a list of characters, ABCD, and then we'd filter looking only for whatever is passed in to look for, say A. So that should leave us with a list of just a single instance of A, which will then count, and then that makes sense. Did I make sense?
I believe so.
Cool. Apparently I did not do something right. I have a feeling that's going to be a very important debugging tool. Checking parens. Number of arguments passed to nucleotide count. Books. Arguments passed. Line 6. Oh. This is calling nucleotide count and not Clojure core Clojure count.
That's why the name is blue and not green. See, I knew there was a reason.
Absolutely. Right, so that's interesting. Okay, how do I call that? Clojure count. So, is it not?
Yes, I think so.
Seems right. I got 0 errors, so I'm going to assume that is correct.
Yes.
Okay. Well, we're down to only 3 failures, so I think we're doing pretty well.
Pretty good, yeah.
Oh, it wants us to throw an error if we got a bad nucleotide. So there are, what is it? What am I looking for? Am I looking for intersection? No, I'm looking for, yeah, maybe I am looking for intersection. So an intersection takes two lists or sequences, two something, some kind of collections, and it will only return items that exist in both. So if we pass our valid list in along with the other list, it should filter out the bad items. Or we could throw or raise an error if we do a difference. I think that's what we need to do to handle this case where they pass in an X. Let's see. Like a new function that is, we'll call it defn valid. Valid. Nook, nook, nook. And accept. It's going to accept. We really got to change the name of this thing. It's going to validate that. So what we need to do that is equals 0. Clojure set difference. Sequence. Yep. Yep. And valid. This is awful. We need to do a little formatting here. That's a little more readable, I think. I'm not sure. So we'll return true if we subtract all of the valid values from the sequence and we're left with nothing.
Mm-hmm.
Otherwise, it will return false. Let's go ahead and test this out and see if it works. Okay, and it was use count. Okay. I think it's telling us that we're redefining count.
Okay.
I think that's
so. We probably have to change that then, right?
Well, they're forcing us to use count, so.
Oh yeah, that's right.
We'll see what happens. Hold on, I gotta go take care of something. I'll be right back. All right, I'm back.
Okay.
I heard all these noises in the other room. I was like, what the heck is going on? And my daughter was freaking out because there was a bug.
Oh, I would freak out too. So.
Okay, so let's try. It doesn't know what that is. So maybe it didn't actually use this. I don't know what's going on here. It doesn't like using count. Never mind. Maybe this will give us a better exception to look at. Oh, this is a really big a stack trace.
Oof.
Already first, but we already. I'm confused because didn't this just work a minute ago? Yeah, maybe it'll stop screaming at us.
Oh no, it hates us.
It hates us. It totally does. On already first closure core count and namespace nucleotide count being replaced by nucleotide count. Oh wait, you know what? I think I actually we don't want. I think the problem here is that it is. I think that is a problem. It's trying to evaluate that, but since I hadn't counted it, it was trying to use the existing count, which is this one here because it had been replaced, but we need to reference it. I don't know. Let's see if this helps.
Where's Derek when you need him?
Oh.
Although he would get mad at us for using the
No, no, no.
So
Like, he'd be like,
so
"What are you
poorly.
insane?" Yeah, it still doesn't like that. Maybe if, do you think that what the heck is going on? Do you think that the order of these matters?
I didn't think it did.
It does either, but maybe if we put the offending function down here, it will help. It doesn't seem to have helped. Oh wait, no, here. Class not found exception, Clojure set. Didn't find Clojure. Oh, it's not. Okay, so that is a different error, which is good.
Yes.
And we want to, I always forget the syntax here. Let me see. I couldn't find it last time, but I think I wrote it down again. Do you remember how to bring that in? Require.
What are we bringing in?
Trying to bring in the Clojure set. Maybe it was like require.
I don't know. It was something like that. I don't remember if you needed that apostrophe there.
Yeah, I don't either. The difference. Maybe. This is probably completely wrong. Runtime exception, end of file starting in line 1. Oh, because I didn't. There I go again, not closing my parens. I think I'd learn. Cons cannot be cast to named. Compiling on line 1. I didn't like my require. Let me look and see if I can find it. If you happen to know it, I'm happy to use your version too.
The require thing?
Yeah.
How do... Well, let's see here. They do... In the tests, they do colon require and then bracket. Then they did bracket Clojure.test colon refer. They did a lot, but I think it's colon require is the big thing.
Okay, so like.
So not apostrophe, yeah, colon require, and then maybe like that.
Look at that. refer. Okay, so these are the ones they want. This is beautiful. Thank you. For that, right?
Yes. There you go.
Okay, so where's that one here? And this is going to count. So that is here. If valid oh, this is amazing.
Oh my god. No one's going to be able to follow what we're doing.
No, they won't. Oh my god, that is beautifully awful. Throw I have no idea how to throw an exception in Clojure.
Yeah, I didn't know how to do that. I did try to do that with one exercise. I have no idea how to properly throw an exception in Clojure.
Let's see. Throw exception. It is surprisingly simple. I assume there's different sorts of exception, but I think that this one, we could probably just stick with exception and see what happens. Okay. So if it, oh no, we want this to be, this is probably horrible form. But if it's valid, then we want to return this. If it's not valid, we want to throw an exception. And we definitely need another paren. But the first step is to make it work, right?
Really?
No, not an exception. I'll just say nyuk, 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 nyuk.
Yeah.
Again. Because we're calling nyuk, 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 nyuk from count. It's barfing again. There's got to be a better way to do this. How do we separate these namespaces? Is it just a matter of prefacing? This with nucleotide count. Seems to work elsewhere. But we're already in the nucleotide count namespace. We're trying to reference count from outside of it, or from inside of it. This gets confusing. See if this helps. Doesn't appear to have helped. So Clojure namespaces. Working with functions with the same name in multiple namespaces. Multiple functions the same. No, that's not what we want. Multi-method? I don't think that's what we want either. I don't think this is what we're looking for. Namespaces. So how do you want to approach this? The problem is that it's making us define a function called count.
Mm-hmm.
But we also want to use the Clojure core count.
Yes.
And once we've defined this count in this namespace, then it's really getting mad at us when we try to use the Clojure core count. What if we required it and called it something else? Is that possible?
That could work.
So if we said Clojure core for count, is there an as counted? No, that's probably totally wrong. I think there was this. To bring in code from other namespaces, I find myself apologizing that it's a bit complex and confusing. Okay. So require Clojure string. Clojure string join. Require Clojure string as string. That might be the syntax we're looking for. But that's a namespace. Clojure string as task Clojure. As string test. Require. If you're interested, you can see more details what happens on the covers. Alias. No. But that looks like it might be useful. Clojure test. Replace already refers. Yes, this is what I want right here. How do I fix this? We just blown away the definitions of replace. Yes, this is what I want to deal with. This is not something I want to do very often in the case of unit tests. Better limit the bars being referred to a name subset. No, that's not what I want. Rename. Yes, rename. Replace string. Yes, that's what I want. Use Clojure. But do I have to use? Well, if it works, I'll use it, right? Use Clojure. Clojure string. Can I? I don't want to say use Clojure core, do I?
Use.
That's already using Clojure core. We'll see what happens. Rename. Name count. What do you want to call count?
Well, we are not good at naming things.
We are not good at naming things. How about to keep with the theme?
Yeah.
Didn't like it.
Of course.
Of course not. Why does it make us call it count?
Don't know. I don't know why they did that. Are we not supposed to use Clojure, the count in Clojure? Or does that not even matter?
I don't know.
Like, are we using count for a reason? Are we supposed to be using count?
I don't know. Maybe we could use a different thing and then just avoid this altogether. Maybe. Yeah, I don't know. See also. No, see alsos. So what are we using it for? We're using it to make sure this is. So in this case, we could probably replace it with. Doing here. Is there an empty? Empty, yes. So in this case, we're checking for a zero length. So empty is probably a better choice, like you said. So let's use empty here, and maybe that will help us. rid of this nonsense. Still have this one. Clojure. Maybe we're okay with this one because this one's inside the count function. Okay, so if the difference is empty, it'll return true, which means it's valid. If it's not empty, it'll return false, which means it's not valid. And yeah, I think you're onto something. Maybe Clojure has other ideas. Okay, so maybe we can change out and not use count here. What is it we're trying to do? We're trying to want to find out how many of them there are. Oh, yes, there is another way we could do this. Reduce. We'd reduce and we'll do it, I think. That is essentially what I want, right? Reduce. Yeah, that's not what I want. Like that. This got confusing fast. So this is going to increment C, and it's going to count. This is going to. What is the 0 doing? Oh. Let's look at reduce because I'm confused. Plus, that's going to add them up. Don't want to add them up. I want to add one up. I want to increment based on. No, I'm doing a reduce and a filter. I just need to do a reduce. So we're going to reduce so that if my brain hurts. So I want to create a function that will return 1 if these are equal. If what's passed into it is equal to nuck, and return 0 if it's not equal to nuck. If it's equal to nuck, I want 1, otherwise I want 0. Pass that into produce. Otherwise, does this make sense? Sort of. So if it's a valid, basically if it's a T, C, or G,
yes,
that we're looking for,
mm-hmm.
then we want to reduce it such that if it is the one we're looking for, we're going to get 1. Otherwise, we're going to get 0. So it's only going to count the ones that are nuck.
Okay.
From this sequence.
Yes.
And if it wasn't one of the valid A, T, C, or G, then we're going to throw an exception.
Okay.
There, I think we avoided using count. Which, I don't know if that's the right way to do it or not, but it should. Come on, we're still using count somewhere?
How is that possible?
How is that even possible?
I thought we deleted it. Or is it just...
Oh, it's still yelling at me. Oh, wait. What's this? Illegal argument exception. Parameter declaration should be a vector. That's just a warning it's giving me. And I am not giving it a vector here. Function. Again. And probably bad form. Expecting var, but exception is mapped to class exception. Let's try throwing an exception. Var, but exception is mapped. Okay, so it is the exception syntax that we're using here. Period?
Period. We don't have a period in there, do we? Is that period supposed to be there?
So I guess that means that it's the, I think what that means is that it's the Java version that we want. It's a Java thing and not a Clojure thing. I wonder if that's the error it's been giving us all along. I don't want to think about that. No. Oh, no, no. sequence cannot be cast to a persistent set. I think. Let's do this. If nucleotide that's passed in is equal to nuc 1, otherwise 0, that looks much better. Fix my, okay. And then the second argument is the sequence. And then this is, yes, I like this better. Clojure does not. Still the same issue.
So he wants us to use count, and Clojure doesn't want us to use count. Is that still the issue?
No, I think we fixed that.
Oh, okay.
We're not using count anymore, but what we are using isn't working. I think I'm using reduce wrong. It's given, not rescue, reduce. So reduce should, I think I'm passing the wrong number of arguments to reduce. I'm passing this. I'm only passing 2 arguments to reduce. Passing sequence. And I'm passing this. And let's test that over here and make sure that that is doing what I think it's doing. So if we said what? Reduce if percent 0. No. A. A percent. No. A. This is doing what I think it's going to do. Oh, I see the problem. It's not add. I'm not telling it to add them. I'm just giving it ones and zeros.
That could be a problem.
Yeah. So I need to tell it to. I need to tell it to add right. How to create a sequence from a long. Okay. Yeah, there we go. Okay, so here we're going to first transform this list so that if use a map to convert this list ABC to ones and zeros. So let's just okay. So we're starting out with ABC and we're converting that to ones and zeros. Does that make sense?
Yes.
Okay, so then we're going to add in the part that just adds it up using the reduce. And that gives us 1. So if we put another A in here, we get 2. That's what we want. We rewrote count.
Yes, we did.
I think that's it. Oh, no.
So close.
So close. Clojure lang strings cannot cast Clojure lang. It's still the same error. What? Oh, it works over there. Reduce with the map. The map is if map if percent 10. Boom, 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 boom. It looks the same to me. It's taking a sequence. If but it's wait, what? Okay. Cast to a persistent set. Clojure lang string sequence cannot be cast to a persistent set. Is that our sequence? What line is this happening on? Team? Error? Maybe? I'm confused. I think it's because do you think it's this count again?
persistent set. Count already. Oh, that's just a warning. But,
yeah, that's just a warning.
But the error. String cannot be cast to persistent set.
Yeah, and string or sequence cannot be cast to a persistent set in this case. What? See if we can get the REPL working. I'm confused. Huh? Unmet. Oh, is this going the wrong direction? Change this nucleotide count. Use. And there's our error. String sequence cannot be cast to a persistent set. What is going on? What if we do sequence? That works. Map. And we just type in substituting sequence. Maybe I'm looking in the wrong area, or we're looking in the wrong area for the error. That works. Try valid. Nuck, nuck, nuck. Let's see. Ha! So difference. Able to resolve symbol difference in this context. Okay, so let's try Clojure set. Here it is. We have these backwards. Contains not supported by a string sequence. Are you as baffled as I am?
Quite. I'm not sure what we did wrong.
Oh, here. cannot be cast as a function. A function? Well, we only need these valid nucleotides in one place, so maybe if we do this, if we go, what is going on? Where's my cursor? So let's try putting them. There. And then if I said persistent set string sequence cannot be cast. What is this making? That's somehow different from this thing. Look the same to me. Oh. 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 Sets. God, I'm stupid. These aren't sets. These are sequences.
Right.
Between sequences. It's like the difference between lists and sets. And oh my God, I'm an idiot. Diff. So if we don't use that and we use this instead, Clojure data. It's not found. Diff. What? That's not what I'm looking for.
No. No.
We could convert. Okay, so here's another option. Take this and we convert these into sets. Set syntax is this, I think. Okay, that works. Oh my God, idiot. Next time I'm being an idiot, straighten me out. Say, hey, Jamal, you're being an idiot.
Is that the Clojure error that's going to come up?
Yeah, totally. It's going to say, Jamal, you're being an idiot. There we go.
Oh, finally. Only 3 failures and no errors.
All of that because of that stupid set. It was a sequence and not a set. And I totally missed that.
I expected this.
Okay, so let's see what we got left. Oh, we're
What's
still using
the difference? Oh, that.
We're still using frequencies. So we just need to convert this to use the count. So we take, this is going to need to take the set sequences, right? Or the, and now that's going to return each item as a set. And we want to map that count. On that yet. Don't on that at all. Oh, we're not getting a. Are we actually returning? Grapple me up. So what does it use? Nucleotide counts. Nucleotide count. And nucleotide counts. See. Return. Interpret operation count not supported on this type character count form. Is this the naming again?
I really hope not.
That. They really made this difficult with that whole namespace thing.
Yeah.
No such var nucleotide count. Nucleotide count. What do you mean no such var? Oh, it's the order, I think. It hasn't been defined yet. Maybe. Worth a try. I said that already. Yeah, it's different error. Wrong number of args past 1 to nucleotide count. Oh.
Wrong number of args.
Because count. Oh, God. No. This is so necessarily difficult. So when I use a map, I want to pass it. I need to look up map because I want to pass. The first argument as this. I don't know how to do this. Doesn't work. The way this is set up, it's like so not functional or something. Okay, so what I want to do is I want to get each of these, each possible. Oh, let me get this. Can't use a map. I need to pass 2. I need to pass full. Right, help me out here, Jonathan. For each one of these things, I want to call count. And put the results into a map.
Right.
So I could stop trying to be fancy. And I could say, they don't like this. There's got to be a better way than this. This is horrible. See what I'm doing here? That makes sense. Apart from the fact that I'm missing a. That makes sense. So I'm just defining a map.
Right.
And that map is going to just have the value for A and the count of A, T the count of T, C the count of C, and G the count of G.
Okay. Yeah.
Okay. So let's see what happens. Of course not. Legal exception duplicate key count. So like that. Hopefully, will resolve. Issue. Duplicate key, nucleotide count. What am I doing wrong? Duplicate key. That's not a key. It's a value. This is the key. Right? Oh, I'm calling it Python style. An idiot again. That should help, right? Please tell me that's going to help.
I feel like you know more Clojure than I do.
I'm pretty sure that's not the case. Yes, one failure. Woo! All right. Oh, we're not throwing the exception because we're never calling it for X in here. Because we switched to this method that's going to... Oh. So this is dumb. That's my official opinion.
Yeah.
I mean, we could... I feel like this isn't the best way to do it.
No, not that, not that I have a better way to do it.
Right. We could throw our check on there again to validate them. So we could just do, let's try something here. Do this. Validate Nook. Oh, that's my favorite part. If valid. Is there an unless in Clojure? Or is that just a Ruby thing? If not, that's what we want. If not, valid nuck nuck nuck. 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 It's almost like we've invented a new language.
Yeah. It's like extremely, extremely hard to use. It's like writing in binary, except everything is 0.
Yeah. I don't really love this solution, but it should pass all the tests. We're putting the logic to validate the nuck 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 into a single function here.
Mm-hmm.
And now we can throw that here. Validate. Nuck. Okay, and now we can get rid of that. Get rid of that. This. Okay, so this should run the validate step, and then that. If it validates, it'll throw an exception, which is what we want. Otherwise, it will just do a map reduce. And now we can go here and do the same thing, throw our validation here. Oops. Validation is in place. Not sure what's happening here. Off by 1. 2. What's this one? Okay. See if this works first of all, and then we can review what it's doing. Of course, it's not working. Wrong number of args past to core if not. Oh. We want if not evaluating, and then what happens. What?
The stack trace of doom.
But we're throwing yuck 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 all over the place.
Yeah, so we were bound to get an error.
So we're backwards. We don't want if not. We want if or when. And but that's not right. When it's valid. When it's valid, we want to throw the exception. If not, I'm confused. When not? Maybe when not is what we want. Not if not. Maybe if not expects 2 parameters and it just flips them. And what we want is when not. Really, when not isn't all that great either. We're throwing exceptions. Let's go out to the REPL because I'm lost. Okay, so use nucleotide. There's got to be someone who ends up watching this that actually knows Clojure.
Yeah, and
they're gonna be like, these jokers, what is this nonsense? They probably have like a single line solution to this. Okay, so first valid. C, D, F. Should be false. Okay. If we go C, T, that should be true. Okay. Now validate. Yuck, yuck, yuck. He should. On exception. That would be a problem. When not. Let's see what when not does. When not false. Not true. When not false, 1. So when evaluating true, when not doesn't do anything. That's exactly what we want. Because valid nuck 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 should come back as true. It should get nothing. It shouldn't be valid. Oh. 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 This is just the next line. It's just a value. It's just running it. So basically we're saying it's like evaluate this and throw an exception rather than throw this exception when this doesn't happen, I think. No, that seems to have worked. What's going on? Throws it in either case. Hey, Oh, I'm gonna feel even dumber than dumb. That's the problem. I didn't write my file. Please tell me that wasn't it. Please tell me it's something else. Okay, it's something else. I don't understand.
This is the throwing the exception part, right?
Yeah. So it's always throwing the exception. But
are we not using when not correctly?
I don't think so, because look, if I say when not valid, okay, let's build this up slowly. So valid, no, key. True. CX false. Makes sense. Because CT is valid and CX is not valid. Then if we say when not X1, we get 1. And when we say not CX CT, which should be valid, we get none. That makes sense? So right now, when it's not valid, we get 1. And when it is valid, we get nothing. Pro exception. There. This should not throw an exception. It does, but not for the right reason. What's going on? What happened? It stopped. That's delimiter. Way. Okay. So we didn't get an exception there because CT is valid, CX is invalid, and we get the exception. That is the exact same thing as this, I think. So why is it that if I say validate nuck, and I give it CX, now I should get the exception, right? Because that would be the same behavior that I'm getting here. And I do. But if I give it a valid string and do the same thing, I get the same exception. It's the same code.
Should those brackets not be there? Is that messing it up?
Yes. That is it. Those ones right there?
Yeah.
Yep, that's it. Thank you. Did it.
Oh, it exploded.
The never-ending failures.
The stack trace from Doom. It's a.
It's still doing it. Still doing it. It's throwing an exception every time. Did I not write that? Why is it still doing it? Oh, wait. Because I'm still an idiot. And I'm still using the brackets here. Okay. Okay. I would have expected that to throw an exception, but it didn't. Oh. We're validating the wrong thing.
Of course.
Are you kidding me? Are you kidding me? Oh my goodness.
Yeah, like I give up.
First, I'm going to go ahead and make this a valid nux again. That's going to be well, thank you. You saved my sanity. Now we just need to make sure that the value is in there. We're almost there. What happens if I do that? Has to function. I shouldn't need to do that. Get. No, not get. I need to figure out if something is in a set. If a value is in a set, what is that? How do I do that? new. Maybe. Oops. No. Okay, Google, I need your help. Clojure is value in set. It's whether a list contains. That might be what I want. Let's see. True. False. We're going to validate our nook, and we're going to validate our nook. I think that we've gotten the longest possible answer. Okay. Now we're validating that. We're validating that. Okay. This doesn't pass tests. It doesn't. That's wrong. Oh. Unable to resolve symbol nook in this context. Oh, because it's here. I think. I don't know anymore. Just don't know. Yes.
Ah.
Oh, okay, so I think this is fairly readable, other than all that nook stuff.
Yeah.
All right, let's see what people say. Criticism, submit, source. Hopefully someone out there can tell us what we did wrong. Where we went astray.
We could always go on and look at other people's answers.
Oh, that is an even better idea.
Well, I'm sure there had to be an easier way
I'm sure there was.
than all those validates and
That was very difficult. Throw this up here. Let me throw, while I'm at it, let me look at the code real quick and. Sorry, I'm thinking out loud. I was just thinking, so these different, we can throw in here too. Be called along the way. frequencies we didn't use, but it was something that was along the same lines. Let's look at my Clojure nucleotide count. What else do we have in here? Difference. Clojure set difference. All right, I'll get those later. Let's take a look and see what other people did. I really hope to look at this and see that only like 100 people have solved this. How do I get to here? Only 198 people have solved this.
Nice.
Okay, now I feel a little bit better.
All right, let's pick one.
Let's take the most recent one.
Oh my god, look at how tiny.
Oh my god. That's 11 lines. It's actually 10 because these.
See, he used frequencies.
He did use frequencies.
And blank start. But that was blank start he had defined.
That's his map.
Oh, and he used merge.
Merge. Okay. So if blank start nucleotide okay, equals 0. So if he doesn't find NUC in our solution, then nucleotide counts if it equals 0. Oh, as opposed to nil. So if it is there, do the nucleotide counts. If it's not there, throw the exception. Okay, this is much better than our solution.
Yeah.
Let's look at another one. Maybe we can go submit another iteration after looking at a few of these. See, they used frequencies.
They did.
Into. What is into? Maps can be into from returns a new collection consisting of I think it dumps one set into another. Yeah. Okay. So let's go back here. So it dumps. See, but notice that they used frequencies, but they never used count in their nucleotide counts thing, which is what I felt it wanted you to do. Otherwise, why have these two functions?
Right.
Which is one of the reasons why we didn't use frequencies. Still, I think it's probably a better answer, but it, like here, this, oh no, this one does use count. Okay, so let's take a look at this. This one uses a reduce. It's going to merge. It's going to merge the, okay, so the output map that is reducing, it's going to merge the value of a particular. Yes, this is what I was trying to do. I just had no idea how to do it. So this is taking this list, evaluating it for each item in that sequence.
Yes.
And creating a map out of it.
Right.
This is what I was trying to do, and I came up with that other thing. The source. This instead. So what we really wanted to do was to make a map that has these elements in it, and then the value for count to be the second part, and that's what this is doing. I'm not sure that's more readable though.
Yeah, I don't know how readable it is compared to some of the other ones.
And they used count. Apparently they didn't have issues with it. Let's try this one. 9 lines. 9 lines.
Containers. Contains. So.
Reduce. Associate. Oh, that's how you make a map, I think. You add things to a map with it. This is This is beautiful. I like this. I want to play with this. Let's try. Okay, yes, so this Jesus count. Just doing a reduce into a map. And that map is going to have items 1, which is going to be the A, T, C, or G, and 2, which is going to be the count. No, that's not right. No, it is. It's associating those into the map. That. Instead of that. Boom. I like that. That's much better. Okay, so here, if it contains that, otherwise throw the exception. Filter. We do a reduce in a map. They're doing just a filter. If it's equal to the nucleotide. Oh, because they're using count. But they used count down here and it worked. You think that maybe we hallucinated not being able to use count?
Hallucinated?
if we do this? What if we say Clojure core count? Okay, so when it's equal to Nook, and then apparently we don't even need to convert it to a sequence. Works. Now I like our answer a lot better. I'm okay with these kind of verbose validations. Mm, I like that better. All right, which one you want to look at?
Let's see. Let's see the 2 iterations. Leetwinski. Yeah.
This one? Okay. I just want to say, Psyduck is an excellent avatar to have when doing Clojure.
Absolutely.
Whoa. Whoa, 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 whoa.
He used Clojure.count in count.
He sure did. Whoa. This looks amazing.
Yeah.
I have no idea what it's doing.
Zip map. Wow.
So zip is going to take zip map. I bet it takes 2 lists and combines them into a map. Chars. This is going to be the first list, and this is going to not be a list. It's going to be a map. So it's going to zip a map and a list together. I like that even better. Because that's more concise. It's easier to read, too. It's going to make a map out of the characters. That's beautiful. I like the zip map version better. We do need to change this to valid nooks. All right. S is going to be chars. Count. It's going to call count. No, that's this is right. This is valid nooks. So the count of each of the valid nooks out of that, make that a map, and then keys values. Returns a map with the keys mapped to the corresponding values. Yeah, that's pretty handy.
Yeah.
I don't know what that's doing. What is a pre?
Yeah, I don't know what that does.
I don't either. That's some kind of magic I haven't learned yet. All right, so did I? Yeah, I put that up there. Cool. I'm going to give this a looks great because I really like that solution. All right. Well, I hope that anyone who does watch this enjoyed how we fumbled around to our solution.
Absolutely.
Definitely. And we will be back sometime soon to do it some more.
Absolutely.
So have a good closuring, and we'll be back soon.